The reason I postponed the quiz was because a few students thought that they hadn't had enough time to do the homework and ask you questions. So that's the reason I postponed the quiz. If you have any questions for the homework, please feel free to ask me now. One of the common questions that I got was, in one of the problems, it should be 3 years versus 2 years, and that is correct. It was just a typo. I mean, not a typo, but it should be 36 months versus 24 months. So if that's your question, then yeah. Any other questions? Yes.
Number 4.
The last one, she did an Excel plot, like when you were drawing it, how many periods did you?
But first of all, just to clarify, it's like, like
I keep making a mistake.
all of you.
So how many periods did you want us to draw that out for?
It'll go to 0.
There's 30 periods.
Well, you can sketch it afterwards. No, the key. Okay, now the question is, why in problem 5, there's a very specific reason I'm asking you to draw a cash flow diagram. Okay? So if you look at it, and if you had drawn it, you will see that the cash flow diagram basically looks like this. Cumulative cash flow diagram, right?
I thought it was like down, up, down, up.
I mean, yeah, if you look at it, it will be like this, but if you look at it, so you convert to make a smooth curve, it will look
But do you connect
like
the
this.
top curve or the bottom points?
Middle curve. I mean, if you look at over 360, you will not even see this. It will be like this, right? So if you draw them, and if you think about it, if you know a little bit of calculus, you can actually figure out this curve by using calculus, right? Because when time is very long, you can treat each year as a continuous time. In that case, you can easily figure out what the shape should be. We'll talk about that in a second. But really the reason for that is, I want you to see that when you're close to the beginning, this is almost flat. What does that mean? It means that all the payment that you're making is essentially going away with for interest. Okay? So that's just how the annuity payments are structured. Right? And so yeah, I'm not, but if you do it in Excel, what's the big deal? Put 360, make a graph.
Well, I thought you wanted us to do the whole payment and go up and then.
Well, Excel can do that in some sense if you connect it point by point. It's not possible. But anyway, my main goal was not necessarily to show God, but really to see this trend. And in the beginning it's very flat, and then it certainly starts to go down very sharply. Okay?
Can you do number 4?
Sorry?
Can you do number 4?
Can I do it what?
Number 4?
Can I finish this?
Oh, I thought you, alright, yeah.
Does anybody have any questions about this? Now, how will you do this using calculus? I'll let you figure it out. Okay? Because
Well, if you gave us, no, never mind. If you gave us like a few points, then maybe we can figure out.
the points are that just use calculus. Just think about what is F versus P. What could be another definition of P mathematically? That is F at what time? F at time 0. That's the hint. And the change in F depends on what? So if you have to think of DF, DF is the change in future value. What is DF equal to? The future value is changing why? Because of
Yeah.
interest. So what should be DF? I times? Well, except that P is the F at time 0. At any other time, F. So DF is IF times what? Sorry? Times I. F times dt, right? Because that's the interest in short time dt. You just have to figure out what this I should be. And then, of course, you know the solution. Right? Does it make sense? Now, in this case, it's a little bit tricky because you have continuous annuity payments. So because of that, there'll be another factor change, right? So if you think about it here, df is going to be equal to f I dt
plus something.
minus A star dt. Right? A star is effectively the annuity divided by 365 or divided by total time on year. Think about it, and as I said, I think you should be able to figure it out from this. This I, of course, is basically the compounding rate of return, assuming continuous compounding. And this A star is the annuity distributed per year. Right? So if dt is in years, then of course A star equals to A. Anyway, think about it. I'm not going to give it to you quick, so don't worry. You're not responsible for this. But I think you are for yourself, right? Okay, anyway. So think about it, and then of course, yeah. And the initial condition is f at time t equal to 0 is p. Right? And of course, you want to solve eventually when f finally goes to 0. I hope you all know how to solve this differential equation. Right? If you could transport with me, you better know how to do it. Okay, all right. So now, the next, what problem do you want me to solve?
4. Did you do that one?
I'm gonna get them both after this class.
4. I came prepared. Shh. No talking. Okay, I signed a mortgage agreement with the bank in 2009 to buy a house for $300,000. The contract required me to make a down payment of 20% and borrow the rest at 6% nominal rate for 30 years. What should the monthly payment be? Okay. So the first part is very straightforward. 300,000 I have to pay, 80% of that, so 240. Right? K equals to annuity. This should be the F or the P. P, right? If you want to use the formula, 1 plus I, where I is going to be I nominal divided by 12. I nominal is 6. 6 divided by 1200. To the power n, where I is 30, so 360 minus 1 divided by I, which is 6 over 1200 times 1 plus 6 over 1200 the power. Right? So you can just calculate it. Is that straightforward?
Yeah.
Yeah, that good?
Mm-hmm.
Okay. Now the question is, I won a lottery in 50,000 and I decide to make a lump sum payment. Okay, so again, there are different ways of looking at it. I think the most convenient way is to look at that time point where you're making the payment, right? And that payment is made after how many years? December 2011. Now, one thing that is not quite clear is, oh no, it is clear. You make a payment on December 31st of 2011, so that means, so you bought the house in January 2009, right? So this is the payment 0. So remember, you start making payments at the end of the month. Now, you also can say, well, but I start making payment on the 1st of next month, and that is quite true, but they are the same time points, right? So you make a payment here. And then you have made December 11, so that will be your 10th year, right? 2 years. So 2 years times 12. So that will be your 24th payment, right? So a 24th payment has 2 payments. Does that make sense? Or is it, no. January, so 2009, 2000, no, I'm sorry, I'm making the same mistake. 36. 36 payment, right? But the 36 payment has 2 payments. Your standard annuity payment plus 50,000, right? Does that make sense to everybody? So you can draw this to be plus P, which is 240K. All these annuity payments. And this payment has an annuity payment and a 50K payment, right? So far so good? Everybody with me? So as I said, there are many ways of looking at it, but I think in this case, the most convenient way is to reevaluate our position at this point in time. reevaluate how much money do we owe, right? And the way to do this would be, of course, bring your principal to this point in time, bring all the annuities to this point in time, right? Okay? Now, you can either just use geometric progression, or if you really understand the annuities, what will be the value of this annuity at this point in time? What is it called?
Future value.
Future value of the annuity, right? So, at this point, the net money you owe is going to be minus P, right? 1 plus I, I'm just going to call it I because I is, just gets over 1200. To the power what? If you bring this money here, to the power what?
36.
36. Plus the payment you have made from the annuity, which is the future value of the annuity. So A, which we already know, right? And 1 plus I to the power 36 minus 1 divided by I. Right? That's the amount of money you would have owed at that point in time if you hadn't won the lottery. But now you won a lottery and you also gave away 50K. Let's just say 50 because we're working in terms of thousands. Right? So this is the net money that you owe. Yeah? Everybody's good? Yeah.
I'm still confused about why the second part of the denominator is not included in the future value of the
This? Because that's just difference between P and I. The principal value of an annuity is the value of the annuity at this point in time. Future value of the annuity is the value at this point in time. The ratio of the two should be the compound interest, which is 1 plus I to the power 36, right? So you can see the only difference is this extra factor. That's because this is the principal value, right? And this is the future value, not at the end of the annuity, but at the point where you're trying to compute it. Yeah.
Why have you put a negative sign in front of that? I would think it would be the opposite.
It's, as I said, it's totally fine as long as you know mind you know.
Okay.
So the net result is going to be a negative result, which means you owe money. But if you want to think of this money owed, then yeah, this will become minus. And this will become minus. This will become minus. It's totally, as I said, it's totally up to you as long as you know what you're computing. So yeah, if you want to call money owed, then that's the money owed. The actual magnitude of the money owed. I was thinking of money owed, it becomes a negative number, that means you owe money. Right? But either way, it's fine as long as you know what you're computing. So you can calculate this, yeah?
Is that P 240?
Yeah, this is 240. A, I don't know. Whatever number you calculate, I don't remember what it is. All right, so now, but if you think about it, this should also be what? Now you want to pay off this remaining balance through the annuity. So this should be the principal value of the annuity starting from there, right? Because you've already taken this payment into account, right? So this payment, so effectively the next payment is going to be made here. So it is just like an annuity. Right? Does it make sense? So this is simply A, which you already know it's the same A. I could have rephrased the problem saying you still want to pay over 30 years. What's the new annuity? In which case you will not know this annuity, but I phrased the problem differently. I said, what is N? So this is so 1 plus I to the power N, where N is the number of months over which you will make the payment, minus 1 divided by I, 1 plus I to the power N. So you solve this N, and that's it. And you can solve this analytically. There's no need for any numerical simulation. There's no need for any numerical calculations. Because from this equation, this is just a known number, right? Everything else is known except 1 plus I to the power n, right? So you can solve for 1 plus I to the power n, and then take log of both sides to calculate n. Yes?
So those two equations equal each other, right?
Yeah. Okay, so that's, yeah, these two are equal to each other. A is whatever your calculator is, and N is what you want to find out. And I is 6 over 12. Okay, so what is that? Does anybody remember what is the annuity you get? Sorry, 4,000? 1,439. so it's a rough, and see here again, you can make a rough guess, right? So you should all get good at it. When you get an answer, you should think if it makes sense. So you're paying, your annuity payment is 1,500. You're paying 50,000. So that's like how many months worth without factoring in interest? 50,000, 1,500. That's roughly 3 years, right? Because each year you're paying about 80,000. So you know that it should pick up roughly between 2 and 3 years of your final payment. So previously you're paying in 30 years, you should be done in roughly around 27 years, right? So yeah, okay. Not quite, it will be less than that because that's just how compounding interest works, right? But anyway, but that will give you a rough value. And so if your answer is totally off, you know you made a mistake somewhere. Okay? Any questions? Yes.
I know this is a ridiculous question, but if it comes out to like, you can't have 204.3 months.
Yeah.
Like if it's 204.3, you should always round up, right, to 205?
Yeah.
Okay.
Oh, yeah, you can write 204.3, that's okay. You will get full credit, right? But of course, in reality, what will happen? In reality, you'll have to make a smaller payment on the last month, right? Okay. So you make a 204-month payment of standard annuity, and the next month payment will be just lower. It will be just whatever is left. Okay, any question? Yeah,
How many questions is the quiz?
I don't. Please don't ask me too many questions about what is in the quiz, how many questions.
Calculator? Do we bring a calculator?
Yes, but you are not allowed to use financial calculator. Okay, you are not allowed to use anything except plus, minus, multiplication, division, and log. Nothing else except that. Well, I guess exponential. And, yeah. But yes, please do not use.
Using graphing though?
You can use a graphing. You do not need graphing.
It's the
So,
only thing we have.
I only have an Inspire.
sorry?
Yeah, that's the only thing I have anymore.
No, you can bring whatever calculator you have. Just make sure you don't use the functions I'm telling you not to use. I'm not asking you to buy new calculators. What it means is that if you're caught using any function that is not approved to use, then it will basically be considered cheating. So yes, you can bring in whatever calculators you have.
But
Sorry?
what?
Yeah, financial calculators which can solve all of these problems. If you know how to plug in everything, they will just do everything for you.
They never check. So as long as it's not finance calculator, which I never seen one. Okay, alright, cool.
But are we taking it here or the DRT?
I'm taking it here. I didn't do it here.
Calculators can do everything we are doing in this class. Well, it means we're not doing much, right? It's okay. I don't pretend to teach anything important anyway. I'm kidding! Not about solving problems, right? Okay, alright. Any other questions of any kind before we move on to the next topic? You all are good on quiz? If you had no trouble doing this homework, I expect you to get 100. The quiz is really simple. There's nothing tricky there, honestly. I like to give some tricky problems. I did not give any tricky problems. There are quite a few problems, I don't know, 4 or 5 or whatever, but they're all easy problems, much like the homework. Okay? Sorry? Okay. Yes, everybody's good? And like I said, we will start here at the regular time. Those of you who only get 1 hour, 15 minutes will leave. And those of you who get double time, they will stay here and we will finish in this room itself. Okay, can I raise everything? All right. Yeah. Sorry? What is what? What's your question?
Eric.
It's on Friday, but yes, those of you only take 50 minutes, you can go early.